All right, guys, let's knock out this practice test video. First one, sketch the graph of the quadratic function. You need to put it in the vertex form first. So I'm trying to change colors here. So I'm going to take out the negative sign first, group my x's together. Leave space to complete the square. Half of 4 is 2. If you square 2, you get a 4, so I can put a plus 4 there. But that 4 right there is really a negative 4 because of the negative sign in the front, so I'm going to put another positive 4 out here. So the standard form of that parabola is going to be x plus 2 squared plus 8, which means my vertex is negative 2 and positive 8. So I'm going to go there, negative 2 and 8 on my graph. The y-intercept, if I put 0 in for x, I would get 4, so the y-intercept is 4. The x-intercept, to find the x-intercept, you got to solve that equation right there. So actually, it doesn't really say you have to do that, but let's go ahead and do it anyway, just because it's so much fun to do. So I have x plus 2 squared plus 8. Move that 8 over first, make it negative 8. This is negative this. They're both negative, so I'm going to take that. I'm just going to divide both sides by negative 1 or drop the negative out. Take the square root of both sides. You get plus or minus 2 on 2 equals x plus 2. So it's going to look weird, but your 2x intercepts are actually negative 2 plus or minus 2 on 2. And you'd have to punch those values in your calculator to exactly where they were. So to get an accurate graph, I'm going to use the fact that quadratics, parabolas are symmetric. And then when I go down here, I'm going over 2, so I'm going to go over 2 that way. Connect the dots, and there it is. Number 2 says find the max, min, domain, and range. All of that is involved with the vertex. So I'm going to do what I did on the last problem. I'm going to find the vertex. I'm going to factor out a 2. Gives me x squared plus 3x. So when you're doing max or min value, that is the y coordinate of the vertex. So I got to find the y coordinate of the vertex. So if I take half of 3, it's 3 over 2. If I square it, it's 9 over 4. That's a 9. 9 over 4, but it's really 2 times 9 over 4, which would be 18 fourths, which is really 9 halves. So I'm going to do minus 9 halves there. So when I simplify all that stuff, I get x plus 3 halves. And here, remember, the half always goes inside. Outside, I'm doing negative 7 times 2, which is negative 14 minus 9, negative 23 over 2. So because it's positive in the front, I got a positive 2. That means the parabola opens up, which means it has a minimum value. And the minimum value is negative 23 over 2. The domain of all the parabolas we've done, because they're opening up or down, is all real numbers, which is that right there. The range, because this is a minimum, the range is the y, so the range goes from the minimum value, and the parabola's going up forever, so that's your range. Number 3, find the local max and min. So they just want the coordinates of the points where the maxes occur and where the mins occur. So the maxes, let's do the max first. There's a max right there, there's a max right there. So one of them is at 0, 0. The other max is at 3, 1. And then the mins. The minimum value, there's a local min there and a local min there. So one of them is at negative 2, negative 2. The other one is at 1, negative 1. Number 4, find the domain and range. Now, again, same kind of deal. I know the domain already. It's a parabola. It's opening down. It's getting wider and wider. It's going left and right forever, so there's your domain. The range, you need the y value. You need the vertex, the y part of the vertex to get your range. So let's do negative b over 2a this time, just to kind of review that a minute. If I do negative b, that's negative 4. A is really negative 1. If you work that out, you're going to get 2. Now, that's the x coordinate of that. I should have put that first. That's the x coordinate of the vertex. To find the y, I've got to take that 2 and plug it in for the x's. So it would look like this. Plus 4 times 2 minus 3. So that's negative 4 plus 8 minus 3. That's actually 1. So 1 would be the max value, because this probably is opening down because of that negative sign. So my range is going to be negative infinity. It's going down forever, and it's going up until it hits the 1. 1 has a bracket because it actually touches the 1. Number 5 says sketch the graph of the function by transferring the parent function. Indicate all x and y intercepts on the graph. Okay, so first of all, let's go y-intercept. Y-intercept, you put 0 in for x. If I do that, that gives you 3 squared, which is 9. So the y-intercept is 9. To find the x-intercept, you put 0 in for the y. Take a square root, move the 3. Only one x-intercept, which is at negative 3, which means when that happens, that means the x-intercept is the vertex. So it's going to open up and just like that. Number 6 is a cubic, and it's got a -4. So one thing, because it's a cubic, I know it goes, and it's a negative cubic. It's negative odd, which means it's going to up to the right, up to the left, down to the right, up to the left, down to the right. The -4 is the y-intercept, so I'm putting a point at -4. To find the x-intercept, you got to solve it. You put 0 in there to find the 0. Remember, 0 is the x-intercept. This is going to be ugly right here. If I move the 4 over, it's 4. Divide by -1, you get -4. So the x-intercept is actually the cube root of -4. You have to punch it in your calculator to figure out exactly what that is. Matter of fact, I'm going to do that right now. It's okay to have a cube root of a -4. By the way, to do cube roots, hit your math button. It's number 4. And I'm getting -1.58, which is about right here, by the way, on the graph. So because I know it's going up to the left, it's going to be looking kind of like this. See, it's going to look like this, and it's going to go down like that. Cubic. It might be on the board, on the wall in the room. Just saying. Number 7, let's find. First of all, I have 3 x's, which means it's cubic, which means it's odd. It's positive because there's not a negative in the front. The zeros are -3, 2, and 4. None of them are squared, so it passes through every one of those. The y-intercept, if you multiplied 3 times -2 times -4, that'd be like 24. The y-intercept is way up in the sky. Okay, so cubic, positive, goes down left, so it's going down left, it's going way up. I'm not even going to make it up there. And it comes back down, comes back up, boom, just like that. Remember, we're not too worried yet about how far exactly up and down it goes in between the zeros, like how far up it goes down here, how far down it goes down here, or up. I know it goes up there to like 24, but couldn't quite get there on my graph. I'm more worried about the basic shape of your graph for this test. Number 8, got to factor number 8 first. So one thing I noticed is they all have x's. X squared, so I'm going to take out an x squared. If I take out the x squared, that leaves me with an x squared, a -3x, and a +2. So I'm going to factor what's left in there. So I have an x squared, x -2, x -1. So my zeros will be 0, 2, and 1. So that's where I'm going to put all of my points in here, 0, 2, and 1. Now, don't forget this, the x is squared. Anytime the 0 is squared, it's going to bounce right there instead of passing all the way through. So be careful there when you draw your graph. The y-intercept is also the 0, 0. Because this is even and positive, both ends are going to go up. So this end's going up, it's going to hit that 0, it's going to bounce up, pass back through, and then go up again. So your graph's going to look very similar to that right there. Number 9, determine the end behavior. Okay, so what I'm seeing is odd, negative, odd, negative, odd, negative. You're always going to write this, by the way. That means the left. This means the right. If it's negative, odd, that means it's going up to the left and down to the right. So when it goes left, the y is going up. When it's going right, the y is going down. And that's how you write that. 10 says determine how many local max and mins this one has. It can have at most 3 because that degree is 4. So what I'm going to do to find out exactly is I'm just going to punch it in the calculator real quick and take a look at it. Okay, when I punch that in, it looks like it definitely has 2 mins and 1 max. And I know I can see the whole graph because it says degree 4, which means it can have 3 at the most, and I see all 3 of them. So how many does it have? It has 3. And that's all it's asking. I'm surprised it's not asking you to find them. Maybe that's coming up. Number 11, factor this one and use the factored form to find the zeros. Okay, so let's sketch the graph. Did this just a second ago. So I'm going P of x equals, I'm going to take out a negative sign and an x because I don't like a negative in the front. If I take an x out of everything, it gives me a quadratic, which makes it easy to factor, but I messed that up. If I take a negative out, that changes all the signs. So it's going to be a minus x minus 12. Let's factor that. Would be x minus 4, x plus 3. So my zeros would be 0, 4, and -3. Those are my zeros right there. So I'm going to make this a little bit bigger. 0, 4, -3. So I have 0, 4 is right here, -3 over here. Now, it started out odd. It's still odd. and it's negative. Odd positive goes down, left, up, right. So odd negative goes up, left, down, right. So I'm gonna draw my graph. It's gonna up to the left. It's gonna pass through there. Pass through there. I missed that one a little bit. I missed all of them. You get the picture. Let's keep going. Got one more. Number 12. A manufacturer finds that the revenue generated by selling X units of a commodity is given by this function. That function is quadratic, by the way. That's a huge deal, which means if you were to graph it, you would get a parabola. Where the revenue, R of X, is measured in dollars, what's the maximum revenue? And how many units should be sold to attain this maximum? Okay, X is the units, R of X is the revenue, revenue. Okay, so, guys, it's a parabola. The maximum always occurs at the vertex. So I'm just going to find the vertex, which means I'm going to do this. I'm going to say X equals negative B over 2A. The B is 80, so I'm going to say negative 80. The A is negative 0.4, so I'm going to do 2 times negative 0.4. And just see what that gives me. Negative 80 divided by 2 times negative 0.4. That's giving me 100. Now 100 is the X. That's the maximum amount of units. So when it says how many units should be manufactured to get the maximum, 100 units. Okay, what is the maximum revenue? I'm going to take that 100 right here, this 100, and I'm going to plug it back in the equation. So I'm going to do 80, that's an 80, times 100 minus 0.4 times 100 squared. And that's going to tell me how much money I can make. So if I punch that in, I'm doing 80 times 100. Sorry about this. I'm actually punching my calculator on the video. Times 100 squared, and I'm getting 4,000. So it'd be 4,000 bucks. So if they sell 100 units, they're gonna make 4,000 bucks, which in this case, given that function, that's the best they could do. That's the max. All right, so hope that helps. Hope you get off to a good start. It's important to get off to a good start because it's a brand new semester. So see you tomorrow when you come in and ace this test. See you, bye.